Very good morning to all. Today we are going to discuss few more questions from haloalkanes and haloarenes. The next question: arrange the following alkyl halides in order of dehydrohalogenation: ethyl iodide, ethyl chloride, ethyl bromide, ethyl fluoride. So we have to arrange them in the options he has given decreasing order. So dehydrohalogenation we have to do. So dehydrohalogenation, that is depends upon the nature of living group. So when compared with that fluorine, chlorine, or bromine, iodine is a good living group than bromine, than chlorine, than fluorine. So which is readily releases from the compound, or which readily acts as a living group that undergo easily dehydrohalogenation. Is it clear? That undergoes easily dehydrohalogenation. Hence, C2H5 ethyl iodide greater than ethyl bromide greater than ethyl chloride greater than ethyl fluoride. So this is depends upon mainly the ability of the living group, which is readily undergoes or readily releases from the compound. Iodine is readily, easily it can release from the compound than bromine than chlorine than fluorine. So ethyl iodide greater than ethyl bromide greater than ethyl chloride greater than ethyl fluoride. Okay, so ethyl iodide, in that iodine is a good living group than bromine. Bromine is good living group than chlorine. Chlorine is good living group than fluorine. So hence option B is a correct. Option B is a correct. Next question. Question number 72. So 2-chloro 2-methyl propane, 2-chloro 2-methyl propane on reaction with alcoholic KOH gives X as the product, gives X as the product. The X is X as the product, then the X is asking. So 2-chloro 2-methyl propane, meth, eth, prop, 2-chloro 2-methyl propane. So if you see that in the presence of what he has given, alcoholic KOH, the product X. So see that alcoholic KOH, what is the role here? It does the dehydrohalogenation. Dehydrohalogenation. What is that? We can say this is a beta elimination also, we can say beta elimination. So this is a alpha carbon attached, this is the beta, this is also beta, this is also beta carbon. So from that any C bond H, it can release that hydrogen and chlorine. So see that, for example, CH3 C, Cl, CH2 H, CH3. So this is beta elimination in the presence of alcoholic KOH gives us CH3, C double bond CH2, CH3. So 1, 2, 3. 2 methyl, 2 methyl pro 1 ene. 2 methyl pro 1 ene is a X. So option C is a correct. Option C is a correct. So 2-chloro-2-methyl propane on reaction with alcoholic KOH forms 2-methyl prop-1-ene, undergoes dehydrohalogenation or beta elimination. Is it clear? For example, instead of alcoholic, if they are given aqueous KOH, they undergoes substitution. Alcoholic KOH elimination. Okay. Next question number 73. Which of the following products, as shown by the dehydrohalogenation of alkyl halides with sodium ethoxide in ethanol, is correctly marked as major product? Correctly marked as major product, which is what is saying correctly marked. So now you see that. So first one, so this is a 1 bromo 1 methyl cyclohexane when reacts with sodium ethoxide in the presence of ethyl alcohol. What he has given there? CH3 plus gives rise to double bond CH2. So he is saying this is a minor, this is a major he has given. So if you see that one, this is undergoes dehydrohalogenation. If you observe that products undergoes dehydrohalogenation. So dehydrohalogenation or elimination, if you observe, already we have seen one rule. What is that? Said-Jeffs. Said-Jeffs or Said-Jeffs rule. What is the Said-Jeffs or Said-Jeffs rule? That resultant alkene will be more substituted. What is that? More substituted alkene is a major product. So here if you observe, around this double bond, 1 methyl, here CH2, here CH2. So this is a more substituted. Here around this double bond, what we are having? 1 CH2 here, 1 CH2 here. Here 2 hydrogens are there. So when compared with this one, this is a more substituted. It must and should be major product, but he has given minor. So this is a wrong, not correctly matched. Then come to the second one. CH3, C, Br, CH2, CH3, CH3 gives rise to sodium ethoxide and ethyl alcohol. The first CH2 double bond C, CH2, CH3, CH3 plus CH3 bond C, CH3 double bond C, H, CH3. So he is saying this is a minor, this is a major group. So if you observe that, same Said-Jeffs or Said-Jeffs we have to consider here also. What is that? This is a less substituted. How we can say? Around this double bond, if you observe here, this carbon attached with one ethyl, another methyl. This carbon attached with 2 hydrogens. So here two alkyl groups are present. If you observe around this double bond, this carbon contains one methyl, another methyl. This carbon contains one hydrogen, another methyl. Total 3 alkyl substituents are there. So this is a major. This is a correct E matched one. Next, another one. Okay, if you see the third one, CH3, C, CH3, CH3, C, CH3Br, CH2, CH3. This is alpha carbon. This is the one beta. This is the one beta. This is the one beta. So this is a beta C bond is present here and here. So he has given C double bond here. This is the one and another here we can see that. So here this double bond attached with one CH, this is the one and this is another. So here total 2 groups. Here around the double bond 1, this is another 2, here one hydrogen, another one methyl. So here 3. So when compared with this one, this is a more substituted. So this is a major. So this is also correct. Hence option C, 2 and 3 are correctly matched as a major product.